This is using Venator to detect macOS compromise. My name is Richie Cyrus. I'm on the defensive services team at Spectre Ops in a senior role. But prior to my time at Spectre Ops, I was actually at Apple on their incident response and forensics team. So as such, I've come across a lot of prompts that look like this on a lot of people's computers. And so we now live in a time where this is no longer true that Macs don't get viruses. Even when they stated that back in the day, Macs did have malware on systems all across America, the US, like globally. Malware existed back then, so kind of a little bit of false advertising. But even so much more today that now APT groups are starting to get interested in macOS malware, where you have the APT 28 group actually creating something like X-Agent. And so this is an upward trend that I see with macOS malware, such that you have very advanced adversaries starting to get their hands on it, create it, and start to use it against organizations they're interested in. And so you're also starting to see the cross-platform rats, such that the rat works on Windows and also is ported to macOS. And so, as I mentioned before, Macs are just like no longer in their own little bubble where they just don't get compromised. And so let's think about Macs in an organization. And so most Macs in an organization are typically issued to those who have the most to lose. And so they're usually like your security team, full of Macs, your developers, your executive teams, because they like to be cool and they want a Mac and they think a Mac is cool. Also, you think about it, nowadays when someone joins an organization, they're given the choice of a Windows computer or a macOS computer. And so when you think about defenses around macOS computers, there's typically none there, it's non-existent, or there's low visibility. And so if you think about the data that's contained on this macOS system, well, usually people have like a VM, which has a Windows system that they're able to connect to, and that Windows system has the ability to connect inside of a domain. Or the credentials used for that macOS system are also good for the Windows domain. And so now you have to think of these Macs as a prime target for data exfil. One, because they're in the hands of folks who have valuable data, whether it be source code, whether it be financials, data that an executive would have. These are things that adversaries know, and now they're starting to go after. So because of this fact, we need security controls in place, not just on Windows computers, but on macOS systems. And so that brings me to threat hunting. And so at some point in time, you have to understand that endpoint security controls will eventually fail or be bypassed. You have to understand this fact. And so on the Windows land, we've already assumed breach. We have the assumed breach mentality, especially when we do hunting. But then on the macOS side, people are still hung up on the fact that Macs don't get viruses. They don't even consider like, hey, this Mac could be already compromised and they're already living inside of my environment. So with enough time, money, effort, an adversary is going to get in. This is not just exclusive to Windows systems. So we have to shift our focus to detecting post-compromise activity and just not relying on all of the tooling and blinky lights that we already have saying this will keep us safe. That's not true. So in order to carry out and actually build robust detections, the number one thing you need to do that, among anything else, is not people, could be technology, but you need data. And so without data itself, good luck trying to find an adversary. You won't be able to do that. And not just data for just data's sake, but are you collecting the right data? The things that you're interested in, do you have the data set to represent what you're trying to detect? For most organizations, they have to take a second look at their data. They haven't thought about this. And so there's tons of tooling on the Windows side, bunch of blog posts around how to do effective Windows threat hunting and what type of data sources you need. For the macOS side, not so much. And so if you think about all the products, these are the top players in the macOS space, how many of you in the room have at least one of these products on your Mac systems in your environment today? Right? You've at least seen at least one of these. And so these products by themselves produce rich data that could be used for hunting. You could leverage that data for hunting purposes and build pretty robust detections. One of the issues that I've come across, not really an issue per se, but I want to present an alternative to you today, is that all of these are agent-based. And so have you thought about the data that this produces, and then also the gaps between data sets between actual products, right? So you have something like OS query, which is basically a pull approach where you tell it what you want to collect, and it basically gives that back to you, as opposed to Carbon Black, which is always like streaming data to you. When somebody executes something on a system, 2 minutes later, a minute later, depending on your pipeline, you actually see that data on that system, right? So this is an alternative that a lot of people haven't thought about, unless you're a consultant or maybe you dug into the weeds on the defensive side. But what if you don't have access to an agent, or you're not allowed to use an agent, right? And so I have a cool compromise assessment story to share with you. So pretty recently I was on a compromise assessment, actually 2 compromise assessments. Both were kind of related. One organization wanted to make sure the other was good before they did merger and acquisition. And so in this compromise assessment, just like any other, they said, yes, please look at our Windows systems. Good, we can do that. Easy peasy. They also said, can you take a look at our macOS systems, where everybody started to freak out. It was like, well, how do we do that? The caveat with that, with the Windows system, was like, yeah, you can't install agent. Cool, we had a platform that kind of helped us to do, like, pull back the data that we needed for analysis. For macOS, we did not, right? So he said, I can't install any of these agents, I can't get the data from any of these agents, and you want me as an external entity to pretty much get that data from your environment and bring it back to my environment and start to do analysis on it. Well, as you can imagine, this was a difficult task. So in the first compromise assessment, we worked with a vendor, and because of the status that that vendor had at this company, they wanted to basically leverage that vendor's tool in order for us to extract out that data. And so we actually reached out to the vendor and said, yes, can you please give us this data set? This is the data that would help us to determine if Macs in the environment have been compromised. That didn't go over too well. They gave us back pretty much like half or 3/4 of what we actually wanted. And so when we started to hunt against this data, it was okay, but it was less than desirable. And so in the second phase of that, the second company had the same vendor, but they didn't even really know how to leverage it. So they said, hey, you guys figure it out. Feel free to do whatever you want. A lot of you might be familiar with Patrick Wardle. He has a bunch of tools out there on objective-c.com. And so we utilized this tool, Knock Knock. And so recently, Knock Knock had a command line argument in it, such that you can actually pull back some JSON from a scan, and then take that JSON and then ingest it into some centralized location. Well, the initial version that he put out actually is an application, and so when you ran this in CLI, the Knock Knock icon continued to bounce while it was scanning, and so they freaked out and said, we don't want this bouncing icon while you're trying to do your assessment across the entire environment. We're like, it's a security tool, like people should be, and they're like, no, we just get rid of it. Cool, so we took a second approach. We used Osx Collector, which is created by the Yelp team. We tried to leverage that, and so that worked out pretty okay, but let me tell you how that went. First, scan, we got all the scans back. The resulting file from Osx Collector is actually a tarball that is gzipped. And so what we had to do was collect all of those gzip files, get them in a centralized location, actually unzip all of those, and then extract out the JSON file that contained the data we were interested in, and then take that JSON file and actually ingest it into our centralized location for hunting. And so that step, that long process was just like agonizing, and we didn't want to go through that again. So we kind of ran into a scenario where one tool was kind of like too hot. They gave us too much data. We had to work through and actually pull out something useful out of that. And one was too cold. We barely got anything. And so we started to think of what would be something that would be just right. And so I have a story about how that came to be. So I was also on a trip with Jared Atkinson, the creator of Get Injected Thread, and also Power Forensics, pretty well known in the defensive community. And then also on the same trip, I was with Roberto Rodriguez, the creator of Helk and the Threat Hunter Playbook. And then you have me. And so as you could imagine, as they're there working on some pretty cool projects that they were coming out with, I was twiddling my thumbs and I started to think, well, what if I started to create this perfect solution? What would those requirements be? And so I wanted to share some of those requirements with you before I move on to the next thing. And so one, if I was to create something out of the box, I want it to be compatible with any Mac ever, right? So basically, if you're running High Sierra or Mojave, even if you just took it out of the wrapper, opened it up, no applications installed, this code should be able to work, right, to extract the data that I want. So that was a requirement. So to leverage that, I use Python. I use native Python for macOS, which is still 2.7, I know, but it's moving toward 3, hopefully, and then I'll rewrite the tool to go to 3, right? Another thing was the output from that, I just wanted a JSON file. I don't want anything else. Just give me JSON. And so every SIM solution that you have can work with JSON files. And once you get that JSON in there, you're able to do some relationships and parse out the fields and build some robust detections based on that data, hopefully. And also from the data that we have existing in that JSON, can we build kind of like external enrichments such that if you have a file, maybe like a hash, you could take that hash and query against VirusTotal. So those are some of the requirements. Also, something that was a pain with Osx Collector, it's designed to be run on a single system when that system is suspected to be compromised. Good luck trying to find, if you're using it in a hunting scenario, if you run it across a lot of hosts and you send that data back in, those JSON files that you get back don't actually have the host name in it. It just has the name of the file, the JSON file, not necessarily the host name it went back to, because the intent is to be run on a single system. So I wanted a tool that could basically, once you find something interesting, you can map it back to a particular host. So I want to give you a demo of the data that Venator provides to you, and then we'll take the next step. So here we see we have ingested data from Venator. And so the first thing that we want to look at is a common persistence mechanism on macOS systems called launch daemons. This is similar to like your Windows services in a way. And so if you look at this data set, you see that, you have a few things in there. You have the hash associated with the binary that's associated with the launch daemon. You also have the OSX name, the host name, module, the path of the actual launch daemon, and then basically the program arguments. What's going to actually run when this launch daemon is started on boot? So we want to take a deeper dive at this. If you do a lot of detection and hunting work, you'll see here that we're about to do long tail analysis, so basically least frequency occurrence, right? And so one of the ways that we could do this is actually take a look at all of the labels. These are like the unique identifiers for every launch daemon. And so if we pull those back, those that are basically least frequent in their environment are more interesting. Or you could just even take a look at the labels and see things that kind of don't make sense. So you see most of them start with COM and then the product name. I know most of these products, you should probably too, Microsoft, Facebook, whatever it might be. But then we see this COM CLAS Trade Pro. It's like, I don't necessarily know what that means. It could be bad, it could be good. Let's take a deeper dive with that. So with that, I want to actually take a look at the term. And the term that I want to look for is the signing info. I want to know, is this binary associated with the launch daemon signed? And come back, we take a look at CLAS Trade Pro and see that it's unsigned. And so as a defender, this kind of raises red flag because things that are unsigned typically don't map back to some entity that's trusted. And so I want to see what host is this launch daemon on, so I could take further actions and send that off to my incident response team or actually take care of that myself. And so here, you see we're going to actually pull back the host name associated with this launch daemon. And so we see we have Pedro's Mac. And so now that we have this information, we could go back into Kibana in our second screen where we could see all of the parsed data and query for Pedro's Mac and see, okay, what else is on that system? And so we scroll, we see we have like several other launch daemons on that system. But then shortly here, you'll see that we'll get to Celestra Trade Pro. And so we identified it. Now we can pull back the hash associated with that weird launch daemon. And so this is part of the enrichment process I talked about, where you could do this automatically or you could do this manually like I'm about to do. you can take this hash associated with the executable and query something like VirusTotal to get an indication of what type of file you're dealing with if it's been exposed to the outside world, right? Someone uploaded it to VirusTotal. So shortly here, we're going to take that hash, copy it, query VirusTotal. If I could type. All right, so now we're at VirusTotal, we put in that hash, and it comes back that this thing could be malicious, you think? Maybe? And so this malware is actually associated with the Lazarus APT group, and so that's something that if I come across in a compromise assessment, I want to take care of right away. All right, and so you're probably wondering, how can I get this data? What does this look like when Venator actually executes, right? What kind of data sources are you giving me in this tool? Well, this is a list of all of the modules within Venator. And so you might be also wondering, well, why the heck did you pick these? Like, what's so special about these? Well, when you're doing point-in-time analysis, when you're doing a scan of an environment at some specific point in time, not on a reoccurring basis like a Carbon Black would do, the assumption that you're making is that an adversary is persisting in the environment, such that the things that you want to pull back are areas that indicate persistence on a system. So if you were to, in a perfect world, go after all of the persistent items for macOS and the likelihood of those items being used, these modules represent the ways that your Mac will probably be compromised if an adversary chooses to persist, right? Survive, reboot. And so that's kind of the reasoning behind just these modules today. But in the future, more will be added. But I started out with these just to be, just for completeness. And so we get all of these modules, but then what does that resulting file look like? You just get one JSON file. And so with that one JSON file, now whatever tool do you have to ingest data into your centralized location, whether that be like FileBeat or some like Splunk indexer, whatever it might be, that can now just consume that JSON file and you never have to worry about it. So let's go into a demo about how that looks from soup to nuts. All right. Here, first I want to show you, this is actually, we're leveraging Helk in the entire time, Roberto Rodriguez's project. And so with that, FileBeat actually has to send some information to Kafka, and then Kafka is going to basically ingest that data into Logstash, and that's how you're able to see in the Kibana. But for my Logstash config, you'll see that for FileBeat, what we're going to do is we're going to have the path such that any .json file is automatically going to be consumed and sent off for ingestion, right? So now we want to run Venator. All you need is Python. You don't need anything else, no external dependencies. We see here that we run it. Oh, we need root. Well, yeah, because I need to parse some artifacts that are, kind of privileged in nature. So that's why. We run the help on this again with sudo privileges, and we see that there's a directory that you can specify. So now that we see that we have all JSON files in the temporary directory is going to be consumed, let's put our output to the temporary directory because we know we're going to get back a JSON file. So Venator is doing its thing. It tells you which stage it is in the collection process. And then at the end here shortly, it'll tell you how long it took, and it'll tell you how many records, and it also tells you the location of that JSON file. So basically, if you forgot where you put it, honestly, or you didn't know what you named it, here's a second reminder. All right, so now this is automatically being sent to that temporary location, and FileBeat is doing this thing behind closed doors, and it's already shipping that data into Logstash, into Kibana, and now we're about to view it here. So last 15 minutes, we see that we get some data back from Venator. And so with this data, what can we look at? What are some of the modules that we've seen previously that we can start to pull apart to identify anomalies and maybe an indicator of suspicious activity? Here, you see again, we are exposed to that rich data set that allows you to build robust detections. But let's take a look at the modules that we have available to us. Let's not go for launch Daemons. That one was pretty easy. Let's look at event taps. So basically, Every macOS keylogger out there in the wild is going to leverage event taps, and so these are the core graphic event taps. And so if I was to build a keylogger, it would be event taps. You can also install a keylogger via like a kernel extension. That's less likely due to the protections that Apple currently has in place. And so let's take a look at our module event taps and actually do the long tail analysis on that data set. All right. So let's look at the tapping process name. So this is the actual process that is registered as a process to do the event tap, right? So this is your external process actually doing the event tapping, right? Tapping into the system resources to get this rich data for keylogging. We see here that we have something called Blue Blood. Everything else is in the system, folder or user bin. Like, Blue Blood looks weird here, so let's take a second look at Blue Blood. And we see that the tap to process ID, basically, if you're using an event tap and you're tapping a specific process, then it'll show you that specific process ID. Anything that comes back as 0 means that it's actually tapping all processes on the system. So, I mean, that's something that a keylogger would be interested in. No matter what process you're in, you're going to be able to keylog that information if you're event tapping all of the processes on the system. So that's why you come back with that process ID of 0. This isn't the actual process ID of 0. You're not mapping that back to like a PID name. It's just saying, hey, we're tapping all processes. And so with Blue Blood, this is weird. We will kick this over to our incident response team and figure out what the heck that is. Now I want to show you basically a day in the life of Venator. So with Venator, I had in mind that as a consultant doing compromise assessments, what would be the best solution for me? This is the perspective of doing a compromise assessment and then using that data to extract out useful information that might indicate yes or no, you might have a problem in your environment. So let's take a tour. So we ingested some data from different hosts, and we have 701 events. And so let's take a look at the module launch agents, right? This is similar to launch daemons, but this is more at you don't need root permissions to actually leverage launch agents. So here we have a lot of the same information we had for launch daemons. We have the host name, we have the executable, and the hash associated with the executable. So these are all things that could probably be enriched. We can use that information to query things externally. So, like we've done in the last two examples, let's do some long tail analysis on the module launch agents. We see we have 24 hits. And then from that, let's take a look at the labels again, because that served a pretty good purpose last time. And so with this, we see that we get a few back. And this is the only one that doesn't have like com in front of it, or it doesn't have anything in front of it or after it at all. So this Meteor Managers is kind of suspicious. I don't know if it's bad or not yet, but I'm hunting, trying to find it out, trying to get some more information. So let me take a look at the program arguments, just to make sure. So with this, you see that this is actually going to spawn Java and is going to execute a .jar file. It's like, already that looks kind of sketchy. Typically when you have a launch agent, it executes a particular thing, right? Media Managers, if you just take a look at that name and you query against it for Google, you see that it's actually associated with like malware. So that might be an indication that, hey, maybe things have gone awry. I need to take a second look at what Media Managers is. Maybe you'll use like some tool to actually take a deeper dive into that jar file. So let's move on to the next thing. So we have this rich data set here, what we're going to take a look at. We see we have some similar information here. This is actually login items. This is another way for folks to persist. When you actually open your Mac and you look at the users, if you look at the next tab next to your users, you'll see all the applications that are designed to start up when the user logs in. So that's something that would be interesting to us. Let's take a look at basically the applications associated with our login items. So we see some of the things that we're familiar with, 1Password for password management, Better Snap tool to kind of snap things in place for macOS. But then we see this final presentation.app. why is a final presentation an application? That's weird to me. So let's take a look at some additional details around that. Let's take a look at the hash of that actual application. So now that we have the hash back for that application, we can now query external sources using that hash, just to make sure that we haven't come across something suspicious. And these are like extremely contrived examples, like you could build detections off of this data, but not as simple as this. And so we see that, hey, like this thing might be bad, we need to kick it off to incident response to start further actions, right? And so the next step we might actually take is to take a look at what host this actually happened on. So let's move on to the last module I'll show you here today, Chrome extensions. This is something that people haven't come across all too often, but with most Chrome extensions, you'll see that the URL, the update URL associated with that Chrome extension actually points back to Google, right? And this indicates that the application itself came from that Google App Store, right? The extension came from the Chrome App Store. Anything outside of that means that someone installed the extension that wasn't in the Chrome official App Store. So let's take a look at that, some of that data using Venator. All right, so we're gonna pull back the extension names here. And we have a few that look familiar. Chrome Media Router isn't suspicious. That actually exists on pretty much everyone's instance of Chrome. But you see we have this YouTube downloader at the bottom. That's typically weird. Like, why do I need to download videos off of YouTube? I could just watch them. YouTube is free. So let's go into the extensions and actually look at the update URL. And so with that, you see all of them kind of point back to Google in some shape or form. And then you see this one is like totally not YouTube downloader.xml. That's not sketchy at all. Let me just continue to have that on my systems. And so if I identify this, I might actually tip this over back to my incident responders or me. Personally, if you're on a small team, you might take care of this yourself. But this is just some of the examples of how you can use Venator to actually pull back this rich data and then start to build detections off of, or start to do long tail analysis, and start to find compromise within your environment. So, future updates. One of the things that we ran into as consultants, which was a pain when we did these 2 compromise assessments, was once you collect all of the data in another person's environment, how do you get that data back to like outside of that environment so you can actually utilize like your own Splunk or your own Elk stack to do analysis on this? Well, most clients basically like give us like access to the share, and then we can access the share, pull it down to our local machine, plug in a USB. That USB holds all of the data that we're interested in. We take that USB back to our system, then we actually take the files off to our system and then ingest that data. That's a pain. And so one of the things that we're actually interested in doing is being able to ship those logs from each endpoint to an S3 bucket that we control. That S3 bucket be controlled by us, kind of locked down, secured, and then from that S3 bucket, do whatever we please with that. So that S3 data can actually be sent directly back into something like Splunk or an Elk stack, or if we just wanted to pull it down and do the analysis locally, we could do that as well. So that's something that we're going to support in a future update. Additional modules, folks would probably be interested in things that are being downloaded to temp, because if you're dealing with macOS malware, they're typically going to utilize temp in some shape or form. And then also downloaded files. How many times have like grandma, grandpa downloaded like Adobe Flash update on their macOS system to the downloads folder, and they downloaded a number of times because the first time they tried to run it, something didn't happen and nothing happened, but now they're laced with a bunch of like different malware variants that are Adobe Flash updater, right? So downloaded files is something that we're interested in. And then something like Bash RC, just things around Bash in general that could be weaponized, and a whole bunch more. Basically, anything that you want to see, this is going to be free and open source. It's already out there on GitHub. If you want to see something in there, pull requests, happy to do it. And so where can I get this? Currently, this This is out there on GitHub. I released a blog post probably a couple days ago. It was Wednesday, I believe, such that I described why there's a need for this type of tooling, and then also a rundown of some of the considerations I went over today about why this tool came to be. And so an alternative way to look at this is like, maybe you have carbon black data or real-time data with any various tool, and you don't have that additional data that will help you say, okay, well, where's all the launch agents, or give me all the launch agents or launch daemons in my environment. Good luck trying to do that with carbon black, because you can't. It's just real-time data, right? So if I wanted to look at the launch agent and then maybe the binary associated with that launch agent, can't happen. But you could get that type of data from OS Query. But that involves you installing OS Query on all of your endpoints, and that's another agent you then have to take control of. Someone has to manage it. Someone has to be careful, about the deployment. It's a headache, right? Probably for that, especially if you don't have many resources to begin with. And so you could utilize something like Venator to give you that additional extra data set, all native to the system without any additional overhead, right? And so that's kind of the idea behind that as well. It's just JSON that you get back. What you do with that JSON is completely up to you, but that data could be valuable to you. And so at this point in time, I will take any questions. My Twitter is @Cyrus. My company that I work for, Spectre Ops, their Twitter is out there as well. You can catch some other things around red teaming, blue teaming, purple teaming in general. And so if you have any questions at this time, I'll take them. Yep.
Does Venator have to be ran against a system that's up and running, or can you run it against an image like that box?
That's a good question. So currently, yes. So the question was, can you run Venator against basically like a dead box like image that you've collected? I haven't tested it against a dead box image, but the intent was for it to be for a live system. So yeah. Any other questions? Yep.
It looks like this is intended to be run locally manually. How would you do it for a 10,000 Mac?
So the question was, this seems like it's intended to be run pretty manually on a local system. How would you leverage it to run it across a fleet of Macs? Well, when we do compromise assessments, people typically, most Mac environments I've come across, have Jamf. And so Jamf has the ability to execute stuff. And so if you give it this Python file, it could execute this across the entire environment to some centralized location, given the parameters. That could be ingested. Also, you could use something like Ansible to possibly help with that as well. So, any other questions, concerns? All right, if not, thank you for your time. You can catch me. I'll answer some more questions offline.